Hi everyone, today I am giving you information on the topic crystalline lens. So let's move to its introduction. Crystalline lens is a transparent, it is biconvex structure of the eyeball. So this one is the crystalline lens and these are the structures of the eyeball. This one is the cornea. Behind the cornea there is an iris. This one is the central space is a pupil and in between here the aqueous humor is filled. So this is the location of the lens and this one is the posterior part where the vitreous as well as the retina comes. Next one, the crystalline lens is a transparent. So it is a transparent in structure. It is a biconvex structure of the eyeball. Biconvex means there is a lens which is biconvex. Both the sides are the convex. That is why it is known as a biconvex structure of the eyeball. Lens is placed between the iris and the vitreous in a saucer shaped depression. As I have shown here that this one is the iris and this one is the vitreous area. So the lens is placed between the iris as well as the vitreous. Next one, lens is avascular in nature. Avascular means there is an absence of blood vessels. There is no blood vessel present inside the lens or in any of the coat of the lens. Lens is asymmetrical oblate spheroid structure. Lens is asymmetrical because we are not be able to divide it into two equal parts. Okay, the shape is oblate spheroid, so we can't divide it into the two equal parts. That is why it is asymmetrical in nature. Lens is suspended by suspensory ligament or the zonules. So the lens which is present here, it is attached with the ciliary body first and then zonular fibers attaches the lens and keep it in a place in between the iris as well as the vitreous. Okay, that was the location of the lens. Layers of lens. So it has different layers: lens capsule, lens cortex and the lens nucleus. Okay, so this one is the structure of the lens from the inside. If you can see here that this one is the center of the nucleus which is known as embryonic nucleus. This one is the fetal nucleus. This one is the infantile nucleus and the fourth one is the adult nucleus. Okay, after the nucleus all these four parts are known as nucleus. Next one, outside the nucleus there is a cortex area. So this one, the whole is the cortex area. After covering the lens, the outside part is the cortex area. Okay, and next one, this one is the anterior capsule. This one is the anterior capsule and this one is the posterior capsule. So we have two capsules. First one is the anterior and second one is the posterior, in which the lens is placed, in which the other layers of the lens are placed and arranged in a manner. Nucleus as well as the cortex are placed in between the anterior capsule as well as the posterior capsule. So dimensions, the dimensions are diameter, thickness and weight. So let's go through it. Diameter, so the diameter of the lens is 6.5 mm at the birth and it keeps on changing as the person become adult, so it becomes 10 mm. Next one is the thickness. The thickness at the time of the birth of the lens is 3.5 mm and at the extreme age it becomes 5 mm. Next one is the weight. The weight of the lens at the 9 years of age, the weight of the lens is 135 gram and at the 40 and 80 years of age its weight becomes increases and becomes the 255 grams. So according to the different structures it has the different surfaces, different measurements, different diameter, etc. Next one is the surfaces. So it has the two surfaces, anterior surface as well as the posterior surface. Anterior surface, as you can see, it is a less convex. Okay, this one is the anterior surface, it is a less convex as compared to the posterior surface, it is a more convex. So according to the convexity, the radius of the anterior surface is 10 mm and the posterior surface is 6 mm. Next one is the refractive index. Refractive index means how much the bending of light will be take from here. It is different for the different materials. It is different for the cornea, different for the aqueous humor, different for the crystalline lens. So the refractive index is 1.39 to 1.42. Okay, because the lens has different surfaces, so according to their surfaces, according to their layers, according to their structure, it has the different refractive indexes. Refractive index will be different from the central nucleus. refractive index will be different from the cortex, and refractive index will be different from the anterior and the posterior capsule. That is why the refractive index varies from 1.39 to 1.42. Next one, total dioptric power. So the dioptric power is 16 to 17 diopters. Refraction through the lens. How the refraction means the bending of light takes place through the lens, and how it can form the rays on the retina and form a clear image on the retina. Lens cause convergence light rays and have a convex surface. As we all know that the lens has the convex surface, so it can cause the convergence of light rays. First of all, the light can be converged by the cornea, and then bending of light takes place through the aqueous humor, and third one is the lens. Lens also helps in the conversion of light rays with the power of 16 to 17 diopters and forming a clear image on the retina by passing through the vitreous. Crystalline lens in the eye lies between the aqueous and the vitreous humor, hence refractive power is nearly about 16 to 17 diopters. Lens is thick and it works as a multiple refractive surfaces. Lens consist of the several layers, different indices, different layers as well as the curvature. Now light first of all reflects through the cornea. Parallel rays of light coming from the infinity are focused at a point which is at the infinity, and then they will pass on to the crystalline lens and forms a clear image on the retina. Here the vitreous structure is there, here aqueous humor structure is there. So first of all pass on through the cornea, then the aqueous humor, then the crystalline lens, then the vitreous, and forming a clear image on the retina. So the 16 to 17 power convergence of light rays contribution is given by the crystalline lens. Thanks for your patience listening.